Good morning, friends. This is the vision and mission of our institute. The vision statement of our institute is fostering a technical excellence through ethics, sustainable education, innovation, and the research. To achieve this vision, we have the four mission statements. Similarly, we have the vision and the mission statements of our computer engineering department. The vision statement of our department is to provide a high quality computer education with socio-moral values. And to achieve this vision, we have the three mission statements. Likewise, we have the three program education objectives of the department. Let's start with chapter number 4, the network layer. Network layer is one of the most important layer in OSI. These are the contents of our chapter 4, including the network layer design issues, communication primitives, that is the unicast, multicast, and the broadcast IP for addressing both classful as well as the classless addressing, subnetting, supernetting, design problems, IPv4 protocol, and the network address translation. And the last one is the IPv6. Then in this unit, we will also study the routing algorithms, including the shortest path, that is the Digitrust algorithm, link state routing algorithm, and the distance vector routing algorithm. Then the routing protocol, including the ARP, RARP, ICMP, IGMP, RIP, and the OSPF. And at the last of this chapter, we will study the different conjunction control algorithms, including the open loop and the closed loop conjunction control, including the token and the leaky bucket algorithms. Basically, three types of the communication primitives are there: unicast, broadcast, and the multicast. Unicast means from one source to the one destination, communication happening from one source to the one destination. That is one-to-one communication. That is the example is the telephone call. Broadcast, the communication happens from one source to the all the possible destinations. That is one-to-all communication. Example is the cable television. And the multicast, that is the communication happens from one source to the multiple selective destinations. That is the one-to-many but selective. And the example is the email communication. Then the next one is the IPv4 addressing. IPv4, that is the Internet Protocol version 4 addressing. The length of the IPv4 is 32-bit number, and the main use of the IPv4 is with help of the IPv4 address, we can identify the any machine or host or computer within the network. So IPv4 basically it is used to uniquely identify the computer in a network. So there are the three ways to write IP address, that is the decimal dotted notation, binary, or the hexadecimal notation. Again, IPv4 addressing comes with the two types. First one is the classful and second is the classless. There are the total 5 subclasses of this IPv4 addressing, including the class A, class B, class C, class D, and the class E. Most of the organization uses the class A, class B, and the class C addressing. Whereas the class D, this is useful for the multicasting purpose. Class E is reserved. This IPv4 address is basically divided into the two parts: network ID and the host ID. Network ID, it identifies the network of an host within the network, whereas the host ID, it identifies the specific host within the network. This is regarding the bifurcation of each and every class here. As shown in the figure here, the first byte in the class A is useful for used as a net ID, and the remaining 3 bytes are used as the host ID. Whereas the class B have the first 2 bytes for the net ID and the remaining 2 bytes for the host ID. In the class C, first 3 bytes are useful for the net ID and the last byte useful as the host ID. Class D, this is useful for the multicasting purpose, and the class C is reserved. And then the table below here is showing the first column is showing the different types of the classes, second column showing the first octet decimal in the each and every class. So the range of the class A varies from 0 to 127, then class B 120 to 191, class C 192 to 223, class D 224 to 239, and the class E is 240 to the 255. The MSB bit in the class A IP address is 0, always 0. In the class B, the first two most significant bits are 10. In the class C, first three bits are 110. In the class 4, 110, and the last one, class C, 4 ones. This is the IP address range of the class A, varies from the 0.0.0002 up to the 127.245.255.255. Likewise, we have the IP range for the other classes also. The subnet marks for the first class, that is the class A, is equal to 255.0.0. So in short, the net ID within the particular class, it indicates the subnet marks. In the class A, we have the first byte for the net ID, and that is equal to the 255. That's why the subnet mask for the class A is 255.0.0.0. Likewise, the subnet mask for the class B is 255.255.0.0, and the subnet mask for the class C is 255.255.255.0. This is regarding the then we have some special IP address range. The first range varies from 169.254.0.0 to the 169.254.255.255, and this range is basically called as a linked local address. Second range, that is specially reserved for the local host, and the third range is 0.0.0.0 up to the 0.255.255.255. Basically, this range belongs to the current or the unspecified network. These are some of the problems associated with the classful addressing. The problem with this classful addressing method is that the millions of the class A addresses are arrested, and the many class B addresses are also unused. Whereas the number of the addresses available in the class C is also small, that it can't be meet the needs of the organization. Class D is useful for the multicasting purpose, whereas the class E is reserved for the future purpose. Due to this limitation, the classful addressing was replaced by the classless interdomain routing in the 1993. Let's solve the numerical here on the basis of this IP addressing. So given numerically that the find the classes of the following IP addresses. So 4 addresses are given here. First address is 1.22.200.10. So here the first byte is 1. So obviously it belongs to the class A here, E here, because the class A, the range of the class A varies from the 0 to 127. Class B 241, the first byte. Class C 227 is the third byte, and the class 4 is 180 byte. 180 first byte. So here since 241, it occurs in between the range of the class E here. So that's why this IP address belongs to the class E. 227 it belongs to the class D here, and the last one 180 belongs to the class B here. Thank you.